After decades of intrigue, conjecture, and endless theories, the James Webb Space Telescope has finally provided something that can potentially change our universe's understanding. The first true high-definition images of Betelgeuse, the red supergiant star, which intrigued researchers and the general public for years with the potential but unknown phenomenon of it blowing up, revealed secrets nobody could have ever dreamed of. For decades, several experts opined that Betelgeuse was about to burst into a tremendous supernova, an astronomical event that would outshine the sun briefly and completely transform our night sky. But what James Webb captured was far beyond expectations, with astronomers left amazed, confused, and eager to learn more. Are we seeing some hitherto unknown celestial phenomenon? Or is Betelgeuse concealing more bizarre secrets than we ever imagined possible? Betelgeuse is the most mysterious and gigantic star in our skies, thrilling generations in awe. Its enormity, about 1,400 times larger than the Sun, and its raging reddish color have rendered it an amateur and researcher favorite target. Located on the shoulder of Orion, Betelgeuse has been a guide in the sky for centuries. But over the last 10 years, it shocked the scientific world. Started to fade, and it faded fast. For so bright a star as Betelgeuse, such a sharp and spectacular fall from brightness was a surprise never before seen by astronomers in recent history. This strange dimming caused ripples of speculation in both the public and scientific communities. Was this the end? Was Betelgeuse going to explode into a supernova? The possibility excited astronomers, as the event would be a one-time experience, even visible in broad daylight. Telescopes everywhere focused on the star, anticipating the grand finale. But despite the excitement, the great explosion never came. Instead, Betelgeuse's brightness fluctuated wildly, dimming, brightening, and dimming again with no apparent pattern. The mystery deepened, and with it, frustration grew. Enter the James Webb Space Telescope, humanity's most sophisticated eye on the universe. Designed to look farther into the cosmos than any previous telescope, Webb was fitted with high-powered infrared tools able to pierce through dust and gas. Although its main objective was to examine the first galaxies following the Big Bang, it also directed its eyes closer to home. Astronomers pointed Webb's accuracy at Betelgeuse, hoping for clarity. What it uncovered was truly astounding. Instead of being a dying spark on the verge of collapse, Betelgeuse existed as a seething cauldron of activity. Its surface, previously considered to be relatively placid, was found to be turbulent, characterized by monstrous hot spots and glowing patches. These were not trivialities. They were enormous areas of disturbance, proof of processes working on scales beyond human understanding. Webb revealed that Betelgeuse was spewing enormous chunks of its outer atmosphere in ferocious stellar mass ejections. These enormous outbursts hurled gas and dust into adjacent space, creating dense, ragged clouds that briefly obscured our line of sight from Earth. What had seemed to be a dying star's fading light was actually the product of these cosmic storms generating a dust veil that obscured the star's radiance. The world had misunderstood its spasms as its death rattle. This discovery put scientists in an uproar, making them rethink the lives and deaths of stars like Betelgeuse. Instead of a serene decline, Betelgeuse's last days might be prolonged chaos, spontaneous outbursts, and violent cycles that remake the star's outer layers over and over. Astronomically speaking, Betelgeuse was shifting in the blink of an eye, fading and flaring in weeks, activity that stunned astrophysicists. The new discoveries kindled controversy. Some contended these explosive convulsions might indicate Betelgeuse is moving toward its final decade, necessitating only a matter of decades before it would burst. Others suggested the star may stay in this unstable phase for hundreds of years before it expires. Regardless of whether one is accurate, the one thing that is true is Betelgeuse is unprecedented, rewriting the book on red supergiant stars in real time. This has staggering implications. The demise of giant stars is not merely a cosmological curiosity. It is the key to the history of the universe. When Betelgeuse eventually blows, it will shoot the building blocks of life into space. Iron, oxygen, carbon, elements that are vital to planets, atmospheres, and living organisms. Each of the atoms within us was once created in the core of a star. To see Betelgeuse come apart is, in effect, to see the cycle of creation itself in motion. The Webb telescope accomplished this by virtue of its phenomenal design. Its segmented gold-coated mirror, 6.5 meters wide, collects the lightest light and looks through cosmic dust that blinds regular telescopes. Without its infrared ability, the reality of Betelgeuse's turbulent surface would never have been unveiled. Every image Webb takes is both a scientific breakthrough and a technological achievement, the result of decades of international teamwork, engineering resourcefulness, and determination in the face of obstacles. Betelgeuse's complicated existence serves to remind us that the universe is dynamic and in flux. The apparently stable night sky is really a platform of ongoing drama. Stars come into being, have radiant but volatile existences, and end in explosions that disseminate matter throughout galaxies. Our own sun will one day change, not in supernova, but by casting its outer layers into space, forging new gas and dust clouds. This cosmic recycling guarantees that the universe is continually replenishing itself, and Betelgeuse is a prime example of the cycle at work. The revelations surrounding Betelgeuse also have implications for future astronomy. By examining its chaotic bursts, scientists are able to fine-tune models of how supernovae ignite, gaining important insights into processes that have been studied only retrospectively until now. If Betelgeuse does blow up in human lifetimes, Webb's current observations are likely to become the most extensive precursor data to a supernova ever captured. That information will shed more light on how such an event structures galaxies, initiates new bursts of star formation, and even affects the dissemination of life-sustaining elements throughout the universe. Aside from the science, there is a field of philosophy in Webb's observation of Betelgeuse. To observe a star spasm and expel its very being into space is to see destruction and creation bound together. From the turmoil of Betelgeuse will be born the seeds of worlds to come. It is a reminder that the universe is not fixed but living, a system in which we are actors, not spectators. At human scale, this is a humbling connection. The atoms in our bodies, the iron in our bloodstream, the calcium in our skeleton were created in the fires of stars like Betelgeuse. To behold it now through Webb's golden eyes is to gaze into a mirror of beginnings, to behold ourselves inscribed in cosmic flame. Its eventual demise will be more than spectacular, but its legacy is already inscribed upon every living creature on Earth. And as the James Webb Space Telescope keeps going on its quest, Betelgeuse is only the start. The telescope will reveal more secrets, from the atmospheres of far-off exoplanets to where the first galaxies were born. Every finding reminds us that the universe is not out there. It is the fabric of our lives. In the stellar dance of stars such as Betelgeuse and their savage beauty and brutal demise, we see the tale of ourselves, tenuous, ephemeral, but inextricably linked to the